So we're talking about Bronsted-Lowry acids and bases. So a Bronsted-Lowry acid donates the H plus in the forward reaction, and a Bronsted-Lowry base accepts the H plus in the forward reaction. If we look at the reaction in the reverse, we can find the conjugate acids and the conjugate bases. So a conjugate acid donates an H plus in the reverse reaction, and a conjugate base accepts the H plus in the reverse reaction. So some examples of these Bronsted-Lowry acids and bases we're going to use the reaction HClO2 plus H2O yields ClO2 minus plus H3O plus. So when we're trying to identify the acids and bases, we need to look at which one accepts the H and which one donates the H. In this reaction, we can see that HClO2 is giving up the H because it becomes ClO2 minus on the other side, and H2O is accepting the H because it becomes H3O plus on this side. So that would make HClO2 our acid and H2O our base. So now let's look at it. Let's look at the reaction in the reverse order, and we can see that ClO2 minus is accepting the H, and H3O plus is giving up that H plus. So we know that this is going to become our conjugate base, and this is our conjugate acid. So when we're looking at conjugate pairs, all conjugate pairs is the acid with their conjugate base, or the base with their conjugate acid. So there are two conjugate pairs in this reaction. One of them is HClO2 with its conjugate base ClO2 minus. And then we also have H2O, the base, with its conjugate acid H3O plus. Another example we can look at to identify the bases and acids are NH3 plus H2O yields NH4 plus OH minus. And in this reaction, we're doing the same thing. We're looking for the compound that gives up the H plus or the one that accepts it. So NH3, we can tell, is giving up, or no, it's taking in the H plus because it becomes NH4 plus over here. And H2O is giving up the H because it becomes OH minus over here. And so this is our base, and this is our acid, and now let's look at it in the reverse reaction, and NH4 plus is giving up the H plus because it's making NH3, and OH minus is accepting the H because it's becoming H2O. So NH4 plus is our conjugate acid, and OH minus is our conjugate base. And when we're looking at conjugate pairs for this one, we have NH3, which is our base, with its conjugate pair NH4 plus. And we have H2O, the acid, with its conjugate pair, OH minus. So now let's look at identifying conjugate acid and base pairs by just looking at the acid or the base. So here we have HClO4, and we know that acids always give up the H plus in a reaction. So the conjugate base is always the acid without the H plus. So for HClO4, its conjugate base would be ClO4 minus, and for H2SO3, we know that our conjugate base would be HSO3 minus. Going the other way, we have HS minus for our conjugate base, and we know that bases always accept the H plus, so this would become H2S, and NO2 minus would become HNO2. And you can go in the other way too. If you look at a base, like here we have ClO minus, and the base again accepts the H plus, so in this example it would become HClO. And then we also have PO4 minus, and if this accepted an H, it would become HPO4 2 minus. If we look at our conjugate acids, the acids are donating the H plus, so NH4 plus would become NH3, and H2SO4 would become HSO4 minus.